والصلاة والسلام على أشرف الأنبياء والمرسلين سيدنا محمد وعلى آله وصحبه وسلم. نيابة عن زملائي وزميلاتي أعضاء اللجنة العلمية، أود أن أرحب بكم في أولى فعاليات المؤتمر الدولي الخامس للإعاقة والتأهيل، والذي نتشرف برعاية خادم الحرمين الشريفين له. كما أرحب بضيوف المملكة الذين قدموا من أكثر من 20 دولة وتعنوا عناء السفر ليشاركونا خبراتهم وتجاربهم، ولتتاح الفرصة للباحثين والمختصين بالتواصل المباشر معهم. لقد تلقت اللجنة العلمية ما يزيد عن 400 ورقة علمية، وتم اختيار ما يزيد عن 160 ورقة منها، وسيتم استعراضها إن شاء الله خلال يومي المؤتمر. وقد توزعت الأوراق العلمية على 94 محاضرة و22 ورشة عمل و44 ملصق. وهنا أتقدم لكل العاملين باللجنة العلمية للمؤتمر وللمتحدثين ولرؤساء الجلسات ولكل من يساهم من عاملين ومتطوعين لإنجاح هذا المؤتمر. ويسعدني وجود معالي الدكتورة تماضر بنت يوسف الرماح نائبة وزير العمل والتنمية الاجتماعية لترأس الجلسة الرئيسية الأولى لهذا اليوم. وفي الختام أسأل الله تعالى أن يكلل الجهود بالنجاح والتوفيق، وأن يديم على بلادنا الأمن والخير والرخاء. والسلام عليكم ورحمة الله وبركاته.
الصوت واضح؟ بسم الله الرحمن الرحيم. السلام عليكم ورحمة الله وبركاته، وأسعد الله صباحكم جميعا بالخير والبركة. وسعيدة جدا أن أكون اليوم في هذا المؤتمر الذي نتطلع له جميعا للحديث عن جهودنا جميعا لخدمة هذه الفئة الغالية والعزيزة علينا في وطننا العزيز. طبعا يأتي هذا المؤتمر في وقت نعمل جميعا على إحداث فرق في تقديم الخدمات للأشخاص ذوي الإعاقة. قبل فترة بسيطة تم الإعلان عن إنشاء وإطلاق هيئة الأشخاص ذوي الإعاقة، وهذا الإعلان أو هذه الهيئة ستكون المظلة بإذن الله لتوحيد الجهود لجميع الجهات المعنية بخدمات الأشخاص ذوي الإعاقة. بالتالي نطمح جميعا أن نوحد الجهود ما بين الوزارات المختصة، ما بين الأشخاص المهتمين، لتكون هذه الهيئة الانطلاقة التي تلم بعثرة الجهود وتنتج وتتوحد الجهود وتنتج بالأخير منتج يصل للشخص الذي يعاني من إعاقة. أيضا لدينا الآن مشروع استراتيجية الأشخاص ذوي الإعاقة، والتي فيها 23 مبادرة، كل المبادرات تصب في خدمة هؤلاء الأشخاص، ومنها إنشاء قاعدة البيانات، والتي من خلالها سننطلق لمعرفة ما هو حجم العمل وما هي الاحتياجات وما هي الجهود التي يجب أن توضع وتصب في خدمة الأشخاص ذوي الإعاقة. أيضا مبادرات التحول الوطني أتت رؤية 2030 بتوجهات جميلة ورائعة لخدمة الوطن، ولم تغفل عن أي مواطن في هذا الوطن، ومنهم الأشخاص ذوي الإعاقة. وضعت تحت رؤية 2030 عدد من البرامج، منها مبادرات التحول الوطني 2020 اللي أحدها تحسين خدمات وفعالية الخدمات المقدمة من الوزارة، من وزارة العمل والتنمية الاجتماعية. وأحد هذه المبادرات هو نمذجة وإسناد مراكز الرعاية الاجتماعية أو عفوا مراكز التأهيل الشامل، والتي تخدم الأشخاص ذوي الإعاقة. والآن نحن بصدد لوضع نموذج وإطار عمل محدد لتقديم الخدمات لمستفيدي هذه المراكز. هذا الحراك الذي نعيشه الآن ما هو إلا تجميع لجهود سابقة، وإن شاء الله نتيجة هذه الجهود سيكون الأثر أكبر. القيادة، الوزارات كلها مهتمة بتقديم خدمات تتناسب وتناسب وتسهل حياة الأشخاص ذوي الإعاقة، ولكن الجهود كانت مبعثرة. الآن والحمد لله بهذه الرؤية وبهذا التوجه الآن تتوحد هذه الجهود والمنتج يكون أكبر وأوضح وأعمق. يسعدني اليوم أن أكون موجودة في هذا المؤتمر، وسأبدأ أنا متحمسة لسماع العروض والأوراق العمل التي ستقدم، وأبدأ مع تعريف بالسيد كريستوفر داوني. هو مهندس عمل في مجال الهندسة لمدة 20 عام، وفقد بعدها بصره في عام 2008، ولكنه استطاع بتحويل هذا الضعف وهذه العقبة التي صادفت في حياته إلى مصدر للقوة والإلهام للإنجاز. قدم الكثير من الأعمال وكثير من الاستشارات في كثير من الدول ما بين الولايات المتحدة الأمريكية وبريطانيا ودبي. إذا تسمحوا لي بس ليكون الحديث أوضح له أنه أقدمه باللغة الإنجليزية. I am honored today to introduce Mr. Christopher Downie, an architect who practiced architecture for 20 years before losing all sight in 2008. This ability that he faced in his life, he used it as a motive, as an empowerment tool to accelerate and bringing together this expertise in architecture and being a blind himself to create and build and support people to give services. And if not him, who then? A person who has the experience. He gave a lot of consultancies and talks and shared his expertise in the United States, United Kingdom, and Dubai. Christopher also teaches accessibility and universal design for the University of California, Berkeley, Department of Architecture, and also involved in 2 federal funded research projects. He served as a board of director for the Lighthouse for the Blind in San Francisco since 2010 and as a president since 2016. He speaks internationally about the architecture and visual impairment and has featured enormous media stories, including the 2015 AIA documentary short, An Architecture's Story. While his TED Talk, Design with the Blind in Mind, has been viewed nearly 1 million times. The American Foundation for the Blind has honored Chris with its 2017 Helen Keller Achievement Award and the Associated Services for the Blind in Philadelphia. Honored him with its 2017 Louis Braille Achievement Award, while the AIA California Council has honored him with the 2016 Norma Salkler Award for Social Responsibility. Most recently, the College of Design in North Carolina State University, where he received his undergraduate degree in architecture, has selected him for its 2017 Distinguished Alumnus Award. Mr. Christopher received his Bachelor in Environmental Design from North Carolina State University in 1984 and his Master's in Architecture from the University of California, Berkeley in 1992. He will talk to us today about the empathetic eye, outsights from the blind avatar. He will take us on a journey to talk about the experience that he had and the fascination of architecture. So please welcome with me Mr. Keristofer Downie.
Let's see. There's a podium out here somewhere. There we are. Let's see. Okay. Good morning. So I'd like to just get started right away. Let's see. Oh, sorry, wrong side. There we go. Okay, now I'm ready. So good morning, and I'd like to get started and see. Oh, I'm not getting the sound. Yeah.
Slide 1. Empathetic colon. Outsights from my blind avatar. Chris Downie, AIA, President, Architecture for the Blind, Commissioner, California Commission on Disability Access, Lecturer, University of California.
Okay, sorry about that. Sorry about my friend. Change this out real quick.
Slower, 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 slower.
Okay.
Slide 2. Lights.
All right. Thank you. Now we are ready. And in fact, what I'd like to do is to go for a walk. Bus stop to Van Ness and okay, so in that video, that sound clip,
Slide 5. Lights on.
that was a recording of me walking through San Francisco, getting off a bus, and walking down the street and into a building that I was to do some work on. And so I hope you had a chance to listen to the different sounds of things that were happening. I'm sure you could hear the traffic, the buses, the trucks, cars going by. But also, hopefully, you could hear the cane, the tapping of the cane, as I walked down the sidewalk and into the building. But what you might not have been hearing was the architecture around me. And that's actually what I'm listening for when I'm tapping my cane on the ground, on the sidewalk, walking down the street, and then walking through a building. I don't listen to the sound coming off the tip of the cane from the ground in front of me. That sound comes out and explodes out into the space, hits surfaces, hits walls and things, and comes back to my ear. And then I can hear how the shape is formed, the shape around me is being formed by the different surfaces. So you can understand architecture to some extent by how you hear architecture. So that's something I had to learn when I was learning to walk with a cane. And I'll advance to that. Still no sound.
Slide 7. Chris walking in San Francisco.
Okay, so that's good. Skipped a few slides there, but part of my training after I lost my sight was for orientation and mobility training. That's learning how to walk around effectively with the white cane, so you can learn how to keep the cane in front of you so it finds things before your kneecaps do, or before your shoes do. But also to find steps, find things all around you so you can navigate on your own. But as I said, I'm also listening to the environment around you based on what I can hear from that feedback. So in this case, this is a photograph of me walking through San Francisco. I've been blind for, maybe about a year at this point, and I was doing quite well. And one thing that surprised me about this experience was not only the experience of learning all this new information about how to walk around and use computers and things like that, but was also how the world around me was changing. It was the same place, but the way I dealt with the people around and the world around me changed a lot. In particular, one thing that struck me after I've been blind for about a year was that when I walked down the street, it used to be that I was always the person that had to dodge to get out of people's way. If they're walking towards me, I'd go to the right or go to the left to avoid walking into them. I always thought that was strange how, if I wasn't the one moving around, how there would be collisions all over the place. And there's a game we used to play, or people used to play in the States back in the 1950s called Chicken, when two cars would drive right at each other to see who would give up at the last minute and miss them so he wouldn't hit. I was playing Chicken. And I realized that I was really awful at playing pedestrian chicken when I was sighted. But then when I lost my sight, what was amazing here is I realized I didn't have to dodge around anymore. My friends would tell me, yeah, everybody's scattering out of your way as you go down the sidewalk. And so I realized at that point that, sorry, lost my, there we go. I had become the super chicken. Is that the chicken up on this slide? Oh, back to, oh gosh.
Slide 9, slide 8, chicken.
Okay. I had become the super chicken walking down the street where everybody dodged out of my way. And it was just funny how the circumstances just changed through that experience.
Slide 9, my avatar.
And with that, it made me realize that I still thought as a sighted designer, as a sighted architect, but I was really living the experience of someone else. Like in this exercise of empathy, when you walk in somebody else's shoes, I felt like I was walking behind somebody else's eyes, or as we do in video games, in an avatar, occupying somebody else's costume, their persona, walking through the environment and experiencing things through that avatar. And I started to realize that I had that kind of relationship between my sighted mind and my blind experience, and how I could really learn from that to affect what I do and really take it as that empathetic experience. So, unfortunately, I think I know what's going on with my computer while it's not working. So, Renzo, could you tell me the slide that's up now? Okay. So, sorry about this. In this case, it's about learning to walk in somebody else's shoes, but as I said, looking through someone else's eyes. Okay, so in these lessons that I learned from my blind avatar, or this experience of being without sight, are things that I call outsights. And you can think of them as insights. Insights, things that you learn, but they're things that I've learned since losing my sight. It's things that I learned as a benefit of having lost my sight. So, okay. So this is a slide of me being, representing being in the hospital after I'd had surgery to remove a brain tumor, and I lost all sense of sight. Everything about the surgery was successful except losing my sight. So there I was trying to imagine what my future might be, how to manage, and all sorts of things coming through my mind. It's impossible at that moment to understand everything that would lay ahead. But there's a lot of training. Is this the different training? I'm sorry? Arrow pointing to my head. Oh, yes. I'm really sorry about this. There's a problem with a delay in the computer, so I'm not hearing what I should be hearing from here. So at first I had to get a lot of training. There's orientation mobility training I've already talked about. There's also technology, learning how to work with computers, and I guarantee I typically do better than I'm doing today with my new computer. It's a little bit different. And then also living skills and learning Braille, all sorts of things to learn. But also in addition to that, what's really important is all sorts of other things. And this hopefully is a photograph of my son Renzo. Is it? Okay, so he's grown up a little bit since then. He was about 10 or 11. And a lot of time we spent together. He kept me engaged in our family and our life and doing things together, all sorts of adventures we had together that weren't part of normal training, but was really really important for maintaining the quality of my life. Also, within 4 months of learning my sight, got out on a tandem bicycle and started riding tandems. I had been an avid cyclist before losing my sight. So the idea of having an energetic, full life as you did before you lost your sight, the sooner you can rebuild those experiences and things is really important. Also went hiking with my son and friends.
Slide 17, skiing.
Oh, there we go. And skiing. Even tried skiing in the first year before I'd been blind for an entire year. And then something that I settled on, something I'd never done with sight, but something I've done for the last 8 years, and that's rowing, which is a great sport if you're blind, because if you look at the slide, nobody's looking where they're going. Their back is in the direction to travel. So like, okay, we're even. And what's amazing about rowing is it's a very multi-sensory sport. So I can hear when the other rowers, when their blade hits the water, I can feel the pull in the boat. I can feel them when they slide back up in the boat. So I can get all sorts of information through things that I can feel, things that I can hear. And if you think about it, with rowing, it's all about rhythm. And you don't see rhythm. You hear and feel rhythm. So I could concentrate on that, and it drives my coaches crazy sometimes that I can follow the stroke better than some of the sighted people because they're trying to match with their eyes when they should be listening and feeling with their body. Sorry.
Slide 19, community and mentors.
And one of the most important things would be a community. People, blind people or people with disabilities to learn from. Because without disabilities, it's really hard to understand that experience, to understand what's possible. If you're sighted, it's hard to see blindness as anything other than you can't see. So it's really important to find other blind experiences, people to learn from, to realize of all the other things that you can do, and maybe you can learn to do better. So you need to learn about the things that you can do, how to do them, to build that community, to build with mentors in that community. So all that gets me to this idea of architecture beyond sight. And if you notice, I very specifically chose beyond sight because it's about taking architecture beyond what architects and designers typically think about in architecture, which is how it looks. And there's so much more to architecture that we don't get to when we stop at the eyes. So in many ways, I feel like my experience in architecture, since I've lost my sight, is more complete, is more full, more rich, has more possibilities than it ever had when I was sighted. And I can still do the visual things. I understand the visual apparatus very well and can still work within that. And much of that experience of the work in architecture now without sight or beyond sight is working with the other senses. And not just one, not just working with hearing, not just working with touch or smell. It's about working with all those things together to make a really rich, meaningful, and informative environment. And part of that is to think about the environmental sensory experience. Typically, 80% of the sensory experience, environmental sensory experience, is vision, is sight. So without sight now, what I'm really focusing in on is all the other senses that are not part of that typical experience.
Slide 24, creative process.
And so I'd like to explain a little bit about the creative process. And one thing I had to realize is that the creative process is intellectual. It's not visual. It's how the mind thinks and how you solve problems and how you recognize things. But without sight, what I really needed was, the creative process was intact.
Slide 26, embossing printer.
I missed what I needed were new tools. And one of the key tools is this embossing printer, which enables me on my own to take drawings that other architects have done in the computer or sketched and scanned into the computer. I can print it in my embossing printer and immediately read the drawing through touch, through the sense of touch. So this is me reading a drawing.
Slide 28, wiki sticks.
And then in a way I've learned to draw myself on the drawings using wax sticks. It was actually a craft toy that my son Renzo had when he was a little kid at a restaurant. And it was just wax, and you can bend it, curl it. You can work in 2 dimensions and 3 dimensions. And I realized it sticks to paper. And so I was able to actually draw on top of the drawings that I was working on, and as a way to develop ideas, share it with other architects, or share it with clients. So in that first year of experience, about 9 months into it, unfortunately that was 2008, and in the United States that was the beginning of a massive economic downturn, and lots of architects lost their jobs, did all sorts of people, and in December of 2008, I lost my job. And I started January of 2009, unemployed, blind for 9 months, trying to figure out what the heck to do. So I put out a call to a friend who is a business coach with architects. Yeah, lost the sound. And explained to him what had happened. And he had an idea. And he reached out to a client that was an architect doing a project that he thought might be appropriate for me to work on. And it turned out to be a project for a polytrauma and blind rehabilitation center for the Department of Veterans Affairs in the United States. And they were building, half of this building was about veterans of the U.S. military that had lost their sight through various circumstances. And the architects were trying to design a building for them, and they weren't so sure they knew really how to do that. And so they thought if they brought me on the team, I have 20 years of experience, but I'm now an architect without sight, and could then be in a position to better design for their veterans experiencing sight loss. So all of a sudden, that idea sort of turned my disability upside down. It made me realize that there was real value in my disability, in my sight loss as an architect.
Turned upside down.
That slide.
Slide 33, architecture for the blind :
So that gets me to architecture of the blind. I'm almost done. How are we doing on time? Okay, so architecture for the blind.
Projects specifically for the blind.
There are projects that I do that are specific to the blind and visually impaired, but then there are others
Projects challenging to the blind.
that are projects like transportation projects or museums that aren't for the blind, but they're important for the blind for various reasons, but they're particularly challenging to the blind. So I'll go through a couple projects really quickly. This project.
Slide 35, vertical tab, polytrauma and blind rehabilitation center, vertical tab.
Okay, so this is the first project I mentioned, the Polytrauma and Blind Rehabilitation Center. Is this the imagery or just a couple? Okay. So this is inside the lobby, the main lobby of the Polytrauma and Blind Rehabilitation Center. The blind rehab was on the second floor. Polytrauma rehabilitation was on the first floor. And I don't have time to explain all that was going on to affect this space, but really worked to make it a more manageable space for the blind veterans. And then there's a therapy garden, a number of therapy gardens, some of them that are for people with polytrauma, and other physical injuries, others that are specific to the blind needs. And some of them overlap. This is another project for the Duke University Eye Center, really thinking about their patients that come there, whether they have significant vision impairments or totally blind, and really trying to design the environment at that hospital, at the eye center, to work better for those patients.
Slide 40, Duke University Eye Center, photo of main reception. Slide 41, Transbay Transit Center vertical tab.
Another project is a transportation project. So, and this is a project in San Francisco.
Slide 42, TTC rendering from above.
And it's a major, 4-block long transportation facility that takes buses from the East Bay that come across the San Francisco Bridge, the Bay Bridge, and into the city. They pull into the station, and there are 47 buses, and you can get off them and get on to work. It's a 4-story building, city park on top. The bus deck is on the 3rd floor, and then there's retail and offices underneath, and a train station underground. And so I was working on that for that blind experience to help commuters that are blind and visually impaired get around the space better.
Slide 44, Independent Living Resource Center vertical tab.
And this is Independent Living Resource Center. I'll go through it really quick. It's an agency that helps people with all types of disabilities, not just blindness.
Slide 45, ILRC reception area. Slide 46, ILRC open office area. Slide 47, ILRC port technology.
And this is some technology, some very new technology that they were working with there that is technology that was developed for not necessarily for people with disabilities, but they installed it here as a test to try to work out the interface so that people that are blind, people that are deaf, people that have mobility impairments, people that can't use their arms can interface with this technology through different means to control the environment, to open doors, to access space. And with this, what was interesting is the executive director of this organization, she was blind. She had been blind all her life. And as an architect, part of what my job was to do, I was the lead architect on this project, part of my job was to make the architectural design process accessible to her. Not just the space, but the process. So the work, the tools, the things that I worked with were things that I could work with her so that she, as the leader, the director of this organization, could be in control, understand what was going on, and really fulfill her role as the executive director.
Tab.
And this is for another agency, the Lighthouse for the Blind in San Francisco. And here, it's a number of the directors, a number of the employees are blind or visually impaired. Not all of them, but then all their students, all the clients that come there, the public that come there, tend to be blind or someone in their family or whatever is blind. This is an organization where I got most of my training. I now serve on their board and the president of board of directors. But at this point, I was their architect, working with another architect to do this work. And it's very much about the blind experience of how you hear space, how you can know where you are based on what you feel. There's lots of things that are happening with this that I don't have time in this talk to go into, but I'll just show a few images.
Another four minutes, please.
4, okay. So I'll just go really quickly through these things. Renzo, if you tell me what's up.
Slide 52, handrail.
On the last stairwell, part of it was working with low vision to make sure that people with low vision conditions could see the stair treads, so they could see that better as they walk up. And this is a handrail. I won't talk about that right now. And we also teach people there how to cook without sight. So this is a teaching kitchen for that.
Slide 54, photo of pre-function space.
And then some training coming around through that space, teaching people how to move.
Slide 55, photo of dormitory room.
Slide
56, photo of accessible control.
And this is a custom design system for AV, audiovisual control, so people that are blind can control the AV system.
Slide 57, vertical tab, sustainability pavilion, vertical tab.
And the final project was work that I'm doing currently on the sustainability pavilion as part of the World Expo, the Expo 2020 in Dubai, opening very soon, in 2020. And that is involving not just blindness, but really working with universal design for thinking about and designing for the user experience for people visiting there through different cultures, different life experiences, different physical experiences, sensory experiences, to work with it to make sure it's accessible to the broadest range possible. And so that's, I know we're a little short on time here. I'm sure I ran long, but I'll just wrap it up and say that a big part of this was really learning to focus on things that you can do and getting past the idea of what you can't do. And perhaps even figuring out ways that you could actually do things that you originally thought you couldn't or others think you can't. So the big part of it is that mental approach of not only the people around you, but you having this idea of possibility, of having that creative spirit to really solve problems and to really focus on what's possible and all the things that actually are quite possible, even without sight. So thank you for your time.
Good job. Thank you, Christopher. That was amazing. Amazing talk, amazing experience, and amazing designs. And how can disability transfer from a weakness to a source of strength? Thank you very much. I'd like to introduce Professor Ike Saiger, Senior Professor at Karolinska Institute. Lifelong interest in neurodegeneration, neural repair, and neurorehabilitation. Leadership role in establishing and developing knowledge applicable for individuals with neurological injuries and ailments. Research interests spanning from stem cell transplantation to quality of life and lifelong perspective in societal re-entry for the affected individuals and societal systems for its responsibilities. 60 years old, married, 7 children, handful. He's a resident in Stockholm, and even though with that much of responsibilities, he has interest in culture, history, and sports. So you are in the right place today. He will talk to us about the desirable involvement of academia in neurorehabilitation, systems approaches with private-public cooperation, a Swedish model. We all know the rapid transformation of neurorehabilitation and how much it has, we have experienced and how much knowledge has been gained. There's a lot of challenges, a lot of coordination, but there's a lot of opportunities. So please welcome with me Professor Saiger.
So I'll just do this. Yes, let me just. No, that's not the right. That's not mine. Yes, this is the one. So thank you. I'll just use this one then. Yes. Well, thank you very much for the introduction. First, I want to thank the organizers for inviting me to this exciting couple of days on disability and rehabilitation. I'm honored to be here, and I want to show you one example of how you may coordinate different simultaneous aspects of rehabilitating people with disability. I'm from Karolinska Institutet in Stockholm, Sweden, and we have a long-standing tradition of specifically targeting the disabilities in the Swedish society, and I'm obviously a university professor and working very closely with the healthcare system in the region. So, as you heard, the title is "This is the Desirable Involvement of Academia in Neurorehabilitation, a Systems Approach with Private-Public Cooperation." We would then naturally call it a Swedish model. It's our way of arriving at something that will take us further. Now, for those of you who don't know Sweden very well, I just give you a little bit of background Sweden has primarily a societal organization of healthcare. Taxes provide almost all funding for also neurorehabilitation. We call it socialized medicine. So everyone will pay taxes according to their ability, in proportion to the income, and then you get resources according to your needs. So it's socialized medicine. Academia is organized in Sweden entirely by the government. So the Karolinska Institute, which is a medical university, is funded by the government itself. Now, individual providers of healthcare may be private, commercial, or private non-profit after signing contracts with the authorities. So it's quite possible to be a private organization, even a commercial organization, and take part in the tax money to provide rehabilitation in this regard. Research and development is co-funded by society through taxes and research grants from foundations and private donors. And last but not least, in my perspective, Karolinska Institutet is the only medical university in Sweden and with a high international ranking. So that is part of the background to my talk. Now, I have spent all my life working on neurorehabilitation, so part of the disability, which is a huge field that deals with injuries or diseases in the nervous system, are things that I've been doing. So I'm going to talk about neurorehabilitation. And I will take as an example the spinal cord injury as another separate part of the neurorehabilitation. So in the greater Stockholm area, Stockholm is the capital of Sweden, and the Stockholm area has 2.2 to 2.5 million people in the catchment area. That's approximately 25% of the population in Sweden. So it's the largest individual region. The societal organization is a systems of care for adults. So everything is organized in consort, and I will describe that a little bit to you. And it goes from the moment of injury, if you have a traumatic injury, to lifelong follow-up. So it's all part of the same system. Now, I will take you through a little bit of the organization of this system of care for the spinal cord injured. I mean, there is a similar type of system also for brain injuries, but I will stay with the spinal cord injuries for the moment. Now, every and any patient that will acquire a spinal cord injury in this large region will come to the university hospital. The university hospital will have the trauma center, neurosurgery, and acute neurology, and will also provide early neurorehab. And it's run by the county itself. So society will organize the university hospital. That is between the healthcare system and in close collaboration with the university just next door. 100% of the patients will come to the university hospital. No patient will go anywhere else acutely. That's a good start, because then you have access to everyone and anyone. After the first few days to weeks, or maybe a month or two, depending on how severe the injury is, the patients will be released from the university hospital to the next level of neurorehabilitation. And there are 3 providers of neurorehabilitation for spinal cord injured individuals. From my left, Rehab Station, which is a private commercial provider which provides inpatient neurorehabilitation. I will come back to the proportions. And then you have Stockholm Sjukhjem, also inpatient neurorehab, but is a private non-profit organization. And the third one is Remeo, which is a small unit, also with inpatient neurorehab and private commercial unit. So why is there a big difference in how many patients that will be admitted to the different units? Well, the rehab station will take all the lower spinal cord injuries, the paraplegics, and some of the higher, the quadriplegics, and preferably the young and middle-aged individuals. So it will be up to 70% of the entire flow of patients. Stockholm Sjukhjem will typically take the older patients that acquire a spinal cord injury and very high quadriplegic injuries. It's a slightly separate unit. And REMEO, which only takes occasional patients, will only admit individuals which have a respiratory problem that will be on a ventilator. So it's very few patients, fortunately. Now, after a few weeks to maybe up to a few months, every patient will then be released to home and admitted to the Spinalis Clinic, which is a lifelong outpatient follow-up unit. And 100% of all the patients in the region will end up being admitted to that outpatient service. That's a private commercial unit provider of healthcare. So this is a system, and I'm going to describe to you a little bit how that works in consort to support the patient from the moment of injury for the rest of their lives. Now, all funding for rehabilitation is tax-based. I just mentioned that. Whereas most funding for research and development are external. Now, as you can see, there is a contract with the Stockholm Health Region for all these providers. So they all have to sign a similar contract saying, we will be part of this chain of events, be it the university hospital or the outpatient service or any other clinic. Now, they share the funds for the rehab for the first 2 years. So on an average, 2 million Swedish kronor is approximately $250,000 US. That is obviously the average cost for the first 2 years. Any individual patient may incur more costs because they have a more severe injury, and each patient will get whatever resources is necessary to go through the whole system up until 2 years. And also, the contract will demand that these different units coordinate and collaborate in order to optimize the outcome long term. So in order to support this, there are frequent meetings where all these different units meet up, discuss individual cases or the policies or the programs to coordinate each other. And the beauty of it is that once you get an injury, there is a certain amount of money allotted. And when the patient will move on in the system, the money will follow the patient. So when the patient will move on, the money will come along, and it all comes off the tax bill. So it actually works pretty well. Each patient will be in a flow. There will be no interruptions in the chain of care from the acute care to the rest of their lives. Now, I'm a university professor, so of course I'm also very interested in the academic skills of these different clinical units. And I just wanted to indicate here, in this system of care, what is the academic competence from the medical university in these different units. And in a scale from 0 to 3, obviously university hospital has a lot of academic skills, but also many of the other units have very significant academic skills that can be integrated. So there are specialist staff of many professions. There are shared positions between the clinic and academia in all units. There are numerous PhD thesis activities that range from master students to university professors, and there is extensive collaboration between the units. So again, there is a glue of academic skill keeping this system together, in addition to the treaty with the health region. Now, I will give you a few examples of what can be achieved once you have a system like this for all the patients in the region lifelong. I will very briefly touch upon many of these just as examples of what we are involved in already and how different types of research questions that can be addressed by having this collaboration. I will start with something which is quite spectacular, actually. The neurosurgical introduction of a neural prosthesis into the severed spinal cord to promote nerve fiber regrowth in the spinal cord combined with intense walking exercise. I think most of us know that the spontaneous regeneration in the central nervous system is relatively poor, or actually very poor. So once you have the injury, there is relatively little or modest recovery of function, certainly after a spinal cord injury. Some 15 years ago, laboratory scientists could show, Olsen and Chen could show at the Karolinska Institute, that in animal experiments you could cut the spinal cord of animals, and then with this type of strategy you could have recovery of function, both walking ability and sensory function. That was quite sensational in those days. There has been technical problems to move that into the clinic. And we're now, as we speak, involved in a first clinical trial where we try to use this particular strategy to actually regain function after a chronic spinal cord injury. There's one controversy in this model, and that is, in order to get this to work, you have to cut the spinal cord, and that has been something that every neurologist and neurorehab person has been very hesitant to do in the past, unless you could project some improvement. So we don't know the result yet, but of course the patient will be found in the outpatient service. They will be referred back to the university hospital for neurosurgery. They will then be treated post-operatively in the inpatient neurorehab, and the 18-month follow-up with intense training will be in the outpatient services. So all the units are necessary to evaluate good results. It's a good example of a systems approach that will be absolutely necessary to get interesting results from this. Only 30 or 40 years ago, when I was a young doctor, most spinal cord injured individuals will die miserably and very early after injury because they had urinary tract infections, pressure ulcers, or kidney failure. And so still, urinary tract infections is one of the major problems on a daily basis, although people do not die anymore from that. So we're now doing a urological survey and developmental management programs to minimize the urinary tract infections and their late complications. And again, in order to do that in an effective way, you need access to the entire prevalence group. So we have a total in the region of 1,200 patients. Although the incidence is only 50 patients per year, we have the full control or contact with all the 1,200 people. So we can actually try to intervene with the annual follow-up programs to reach every patient in the region, not only certain patients, but everyone. Most rehab centers concentrate a lot on physical training for very natural reasons. You try to regain strength and physical ability. Now, we haven't really, everyone does that, also in Stockholm, and we haven't really been really knowledgeable about what happens other than strengthening the remaining muscles' power. What happens with the metabolism? What happens with the energy expenditure once you train and only part of your body is still functioning? So we're investigating the energy expenditure and metabolic implication of physical activity and exercise, and we develop recommendations for health promotion. If you are by force with a paralysis, live a sedentary life in a wheelchair and you cannot move a lot, you have obvious problems with diabetes, obesity, and metabolic syndromes, and you may die or at least be ill from myocardial infarction or other cardiovascular diseases. And so it's a real threat to quality of life and even survival. So this is a very important addition to the training strategies that we all are involved in. And I think this is going to be important for the future in every and any neuro rehab training institute that you will see. Well, if you have a high spinal cord injury, it is not possible for yourself, if you have bad hands, to empty the urinary bladder yourself, because the hands wouldn't allow that. So many of those individuals who have quadriplegic injuries, they will need an indwelling catheter. And today the modern indwelling catheter would be the suprapubic catheter. Still, these individuals are ridden by a lot of urinary tract infections. So we're trying to optimize the materials that these urinary tract catheters are being used made of, which is a very significant possibility to improve the quality of life of these individuals. Now, even in the highly organized Swedish society, no more than 50% of the people that are afflicted by a spinal cord injury return to work. And we think that is way too bad. We would like to increase that dramatically. Of course, if you fall off the scaffold and you're a building constructor, then you may not be able to go back to the same work. You may have to be retrained or re-educated to have a different type of work. But many individuals in the society have office jobs or physically not so straining jobs, and then the possibility to go back to your previous work would be quite possible if society would organize the support systems for that. So we only have a 50% success rate in going back to work, making your own money, supporting yourself in society. So we have started a huge project in the entire region with strict coordination between the neurorehabilitation and a number of societal stakeholders, insurance companies, healthcare systems, of course, the patient and his or her relatives, obviously, but also workplace adaptations and most certainly also adaptation of the home environment. So there are lots and lots of things that you can do to improve the possibility to go back to a regular work situation. Now, if you have a spinal cord injury and you may be able to walk with crutches or some support, or you are in a wheelchair, chances that you will fall over is markedly increased compared with able-bodied individuals. It may be transfers from the bed to a wheelchair, from the wheelchair to a bathroom, or into and out of a car, or other situations where you would actually move around in society or in your home. And the risk of falling over and actually hurting yourself is quite significant. So it's sort of a silent problem in society. Many people fall over, old people fall over, sports activity persons would fall over, but the spinal cord injured individuals will fall much more frequently. So we're doing risk assessment and consequences of falls in the whole regional prevalence population of spinal cord injured individuals. So we can catch all of them. We can see the frequency and the severity of those particular predicaments. We also, as part of the outpatient service, we have annual checkups of all the inborn dysfunctions of the spinal cord with the spina bifida. More than 200 individuals, adult individuals, live in the Stockholm area with spina bifida. Only 30 years ago, most of them did not survive past 5 years. Now, almost all of these individuals will live long lives. We have individuals in their 60s and 70s who have lived a very fruitful and very lively life out in society with a spina bifida inborn disorder. So the problem is that there are many ongoing situations where these individuals would need an extensive support. So we have to look into that as well. And finally, I'm going to just mention that the annual incidence, which is a very difficult thing to find unless you catch the entire population, the annual incidence of spinal cord injury is important not only for planners of healthcare situation, but also for the individual hospitals or rehab centers. So we looked at the incidence in the Greater Stockholm area in the mid-90s, mid-2000s, and mid-2010s, every 10 years. And we in Sweden have a very stable incidence, which is just under 20 new injuries per 1 million people. That's a relatively low figure by international standards. The lowest figures you would find would be Holland and Norway and a few other West European countries, and that would be in the order of 15 per million. Even in the United States, the figure would be like 50, and there are unmentioned countries that would be up to 100 to 120 cases per million people. So that is one thing. It's very stable. The incidence is very stable in Sweden. But the interesting thing is, what are the causes of the acquired spinal cord injuries? And that things change. So in Sweden, for example, we used to have a lot of traffic accidents, traumatic traffic accidents. Now, with the zero tolerance situation in Sweden with regard to traffic situations, the traffic accident associated spinal cord injuries dropped dramatically. So now most of the individuals that have a spinal cord injury will be accidental falls. In other parts of the world, there may be criminal violence, like South Africa and other countries, where the majority of the cases would be criminal violence, or the vast majority of cases in Thailand and the United States, for example, would be traffic accidents. So the individual country will have a different profile of the causes of the injury. Now, another thing that changes is that it used to be that the maverick 18 to 24-year-old young men would get injured because they would go too fast on a motorbike or they would do daring things. So it would be young people. Now, that has changed dramatically all over the world. So the typical person who get an affliction by a traumatic spinal cord injury is now a 40 to 50-year-old man or woman. So although the number of cases is pretty much similar, the profile of the individuals that are afflicted will change. So I will end up by giving you just what I regard as the 9 steps to develop excellent neurorehabilitation. How does the research and development come into play? There may be added another 10th step, I don't know, but these are the ones that we have arrived at. You need efficiently organized clinical activities, seemingly obvious. You need highly specialized care units. You need integrated research and development activities at the sites. You need close affiliations with academic entities. We are very fortunate in Stockholm to have that to a large extent. You need significant research and development funding, which is difficult, I think, everywhere in the world, but it is important. You need to network with other prominent caregivers in your rehabilitation. Regionally, if there are such ones, certainly nationally, and definitely internationally, to pick up the best possibility and best ideas from other parts of the world. You need evidence-based strategies rather than tradition and care programs. You need exchange of knowledge and experience internally as well as with others. And last but not least, the rocket science is implementation of new knowledge with shortest possible delay as a basis for evidence-based care, EBC. Now it's interesting, even in Sweden, where we think we have a highly developed healthcare system and good academic research, there's a mind-boggling 10 to 20 years before new data from research will actually reach the patient. So there's a lot of things that we can do to shorten the lag time between new information and the actual implementation in the clinical arena. And then I think the continuous dialogue between the researchers, whoever that is, with the clinical interest and knowledge, and the clinicians with an academic interest and knowledge, continuous dialogue would shorten that period dramatically. And hopefully in the future we will have only like 3 or 5 years lag time before new data will actually reach the patient. So it's a major frustration for the system in Sweden, and I think all over the world. We have, even at the big university hospitals, we can find ourselves doing clinical work but not including the latest results from research. So this would be the Swedish model of how this could be conducted. And whether or not this is applicable in other parts of the world with other societies is a matter of further discussion. So thank you.
Thank you, Professor Saiger. And I think with this beautiful experience you shared with us, it leaves us all with it's an eye-opener. It leaves us with a lot to think about of how we can apply this experience and make use of this knowledge that we gained today. Thank you very much. Please allow me to introduce Professor Saeed Bouhlega, King Salman Prize Award winner, consultant neurologist, neurophysiologist, King Faisal Specialist Hospital and Research Center, 38 years of clinical and academic work at King Faisal Specialist Hospital and Research Center, received 7 boards in neurology and neurophysiology, USA and Canada, published over 155 papers, worked at national and international levels, program director for medicine 5 years, section head for 7 years, and chairman of Department of Neuroscience 4 years. founder and chairman of the Saudi Board of Neurology for 10 years, founder and chairman for Saudi Neurology Society for 8 years. Organized many symposiums at national and international levels for 20 years and worked at many committees at all levels, clinical scientist at King Faisal Research Center. He will talk to us today about the motor disability in Saudi Arabia current view, and I have to say, being an academic and neuroradiology, worked in the field for several years, I've always admired your work, Professor Bouhlega, and the level of clinical passion that he has for his patient and the clinical care he provides. Thank you very much for being here. This floor is yours.
Thank you. Thank you, Tamara. Thank you, the audience. Bismillah ar-Rahman ar-Rahim. Assalamu alaikum jami'an. Good morning, everybody. First, very great thanks to King Salman Center for this ability to give me this opportunity. Thank you for the organizing committee, scientific committee. What Tamara meant that I'm an old man and at the end of my career. So I hope that you will enjoy 20 minutes of some of the things we did over the last 10 years or so. My subject is a bit different than the other two speakers. I will talk about, as a neurologist, as a clinician, I will talk about what I see most of the days. Either we deal with central nervous system or peripheral nervous system. So today I will talk a little bit about the peripheral nervous system. Although it has only the nerve cells, the axon, and the muscle, more than 1,200 disorders is being known to cause peripheral disorders. By and large, most of these disorders are genetic and mainly autosomal recessive. So just imagine the burden of these disorders. Very little disorder are disimmune. I don't know if we have a mouse here or pointer. Anyway, very little number is disimmune or inflammatory based or like by some other toxic also. Among them, we have the dystrophy. This is our subject. This is a disorder. This is an unusual disorder. Actually starts with progressive muscle weakness, mainly in the pelvic or in the scapular region. About 95% autosomal recessive, so consanguinity again plays a big factor. Why we call it dystrophy? Because there's a muscle degeneration and regeneration, and then fibrosis. So this is what will happen over the years, take about 5 or 10 years or 15 years until the patient become disabled. Most of the time, but not always, the CK or the muscle enzyme get elevated. So if you look at this kind of definition, it has a bit loose definition. So any muscle weakness, we'll call it muscle dystrophy. There's a lot of variability on the age of onset, progression. It's fairly unspecific. And actually, when we were in medical school, we used to call it a basket of unknown muscle disorder. To understand this, if you look at the sacroilimbal membrane, if the middle part is the muscle fiber, about 150 years ago, we didn't know anything about it. And Duchenne, when he started in 1860, he said, Duchenne is a boy disease or a man disease. And then over the last basically 30, 40 years, we discover all these proteins. You see there's about 27 proteins. The proteins are distributed either in the sacroilimbal, in the muscle, the cell, the membrane of the muscle fiber, like in dystrophin, the first one, sarcoglycan. You can see the dystrophin is down there. Or it can work in the sarcomere contraction, like the myosin and actin or scalpin. It may work in the nucleus itself, like in case of laminin, or in cell homeostasis, like fucotin and pimont. So there's so many proteins, and any defect in one of these proteins will go to the same picture. This is to summarize these things. Currently, we have 27 sub-entity of these things, and in Saudi Arabia, we don't know the situation. Which one is the most common, which is less common? And although most of the time it doesn't have a treatment, but I'll give you some example that this is of very great importance. not only to prevent disability, but also to help in the cost containment. So this is the map of the world with the common limb girdle muscular dystrophy. If you see it, for example, in the United States, the type, what we call it dysferlinopathy. Dysferlinopathy is the gene or the protein involved dysferlin. So in the state, for example, dysferlinopathy is the most common one. In Brazil, on the other hand, a condition known as calpain. Okay, and as this is the same like in Russia, for example. If you look at Saudi Arabia and many other countries, we don't know what has happened. In Sweden, for example, we have something called ANO5 or LMG2L. So to make it more difficult, even the phenotype is different. If this is the picture of all the known type of limb girdle. If it's green, it means slow. It may take 20, 30 years. If it's red, it may take a few years. And if it's yellow, it can go in between. So if you see the phenotype is very variable. It may affect cognition. It may affect cardiac. People who work in the pediatric may know that they may go in respiratory failure. So again, it's not only the diagnosis, how to deal with this, how to tailor the resources to look at these things, how to prevent contraction and so on. So it's not only diagnosis, also a long-term problem. But again, this is an ethnic-related issue. Not all dysferlin is the same in North America and in Saudi Arabia. And up to a few years ago, this was our best way to diagnose limb girdle. We have a control. We take an antibody, we stain it against the antibody and see if it's deficient. We call it dysferlin, for example. The first one is dystrophin, the second one is dysferlin, and so on. So this was our case until we, and with the help of King Salman Center for Disability and King Abdulaziz City for Science Technology, we looked at our database. We looked at 55 families with limb girdle muscular dystrophy and said, what happened in these cases? What do we have? What are the genotype, phenotype? So we started by, as I said, looking at these 55 families. Most of these families are autosomal recessive. This is an example of family pedigrees. And we start by doing what we call initially homozygosity screening. So we took all the known genes, for example, dysferlin, the first one, calpain is this, and see when there's a homozygosity, most likely this is the gene. So for example, in this cartoon, the calpain was the homozygous in this family, so we know this is the calpainopathies family. But it wasn't easy. Out of 55 families, we could sort only a few of them. This is the family, and this is the different gene. If the color red, the family is linked to one gene. If it's green, for example, the second family, it has two genes. If it's blue, it is three genes. If there's no color, we don't know the gene. So most of the time, we could not find the responsible gene. So these are the known genes in our families, and we could sort only 40%. That's 20 families could sorted with homozygosity mapping. So we still have about 60%. We don't know the cause of them, of the underlying gene. So what we did, as many people do, and thanks for the Saudi Genome Project and the money put in that thing, we start to do what we call now NGS or next generation sequencing. As you know, the NGS, it can be either targeted or non-targeted. The non-targeted is the one which has been going for almost 2 decades. We take a DNA, we do a whole exome, a whole genome sequencing. This costs about $1,000 to $50,000 US, and will take up to months or even years, and the yield is very low. While on the other hand, the targeted, in this side of the picture, you can make a library, you can take any genes, any number of genes, put them in a template, you can create a template, then you take saliva or a little bit of DNA, and run it within 1 day, you can screen hundreds of genes. And you see how the yield, and it costs now less than $200. So instead of wasting thousands of dollars, long months, now we can get the diagnosis within 1 month. And this is where the future is. This is what we call now NGS. So Obviously, the NGS is not a simple machine. You need a big informatic department. I know in the Saudi Genome project, in the King, in the CAS, in King Faisal Hospital, we have a bioinformatic department, because data has to be filtered. It has to be seen if this correlates with the known mutation. So we start, for example, with 1,100 variant, and then you take the non-coding, you take the common SNPs, and you end up having 1 or 2. And you're lucky if you have an 112, then you can confirm it by doing genetic segregation and so on. So this is a very good tool. So when we took our families and we did the NGS, we were able to verify almost 88%, from 40% to 88%. This obviously, it added a lot of knowledge in a short period of time. It shows you the power of the collaboration between the clinician as well as the genetist and other aspects of research. We also found that these are the most common one. In Saudi Arabia, we have what we call dysferlin, is the most common one. This initially described by a Japanese clinician called Mayoshi, and then Calvin and so on. By the way, we have sarcoglycan, number 4. When it was discovered, it discovered in between Qatar and Kuwait, and the people who discovered call it adal, min adala. We call it adaline, but obviously quickly it went to be sarcoglycan A, so another one. So let's talk a little bit about Mayoshi, which is the most common one. The Mayoshi is a disease, the most common limb girdle muscular dystrophy. It may affect either the proximal muscle or the distal muscle. If it affects the distal muscle, affects the posterior aspect, we call it the Mayoshi phenotype. It affects mainly the gastrocnemi. And the imaging for Dr. Tamadar can be even preceding the clinical picture by looking at this. And it may be mistaken as polymyositis. It's very important because I will tell you this. Many patients, they came to us with diagnosis of polymyositis. We found in about 40 patients that they tend to have calf and deltoid hypertrophy. And that also they have elevated liver enzymes. Some of them may present with only high CK. It can be asymmetrical for a surprise. And as I mentioned, steroid may make it very worse. If you give them a steroid, they become wheelchaired within weeks. It's a very important note. So this is an example. You see the posterior calf component in one family. There's 5 or 6. It usually start at age of 15 or 16. This is a peculiar for a clinician. I know there's not so many clinicians. They have this, what we call deltoid sparing phenomena. See, the deltoid, almost everybody is spared for unknown reason. The disease itself can be variable among male and female, among the same family. For example, in this family, the young sister has what we call Mayoshi phenotype, the posterior, while in the older brother, he has the limb girdle. So the same family with the same mutation, the phenotype is different, to make this very difficult. So this is the dysferlin. This is the way we do the antibodies. If you do a muscle biopsy, the muscle biopsy is inflammatory by and large, and even it has the CD8 and CD6 indicating this may be some inflammation. This is a bit interesting. When we look at all our family with dysferlinopathies, we have 20 families. And if you see, this is a different mutation. The red mutation is one founder mutation. So almost 70% of our patients has a founder mutation. And these families, they came from west to mid area. So there's a between Typhon and Duodemy, this is where the mutation came. And the mutation is almost 700 years old. Okay? So we have Mayoshi in Saudi Arabia for 700 years, and nobody diagnosed it. And obviously, because of consanguinity, it became very apparent. And you see, it started in the west, northwest, came to the middle part of Saudi Arabia, and then relative to the east. So we can ascertain where this gene came, and hopefully we can prevent, having more cases with antenatal diagnosis and so on. This is also the same thing in Saudi Arabia, sorry, in other neighboring countries. So this is Saudi Arabia, I showed you, from Emirates, from India, as well as from Iran. They have the same thing. If you look at the homozygosity mapping of the whole world, Saudi Arabia and this part of the world has the most common homozygosity by doing haplotyping. About 80% of people in Saudi Arabia, especially in the west and the south part, have the same like haplotype. Before we end, I'll just give you two cases. So how can, many people said, this is all academic, how does it affect us, The first patient is a college student. He's an engineering college student. He was well until 1 year when he started to have back pain and leg pain. Having pain means indicating there's some inflammation going on. He could not stand in his toes. His CK, the muscle enzyme, was 6,500. The liver enzymes was very high. So if there's any clinician or neurologist, high CK and high ALT indicate a unique phenomenon. In yellow here, he was diagnosed as polymyositis, received steroid for 4 or 5 weeks, and he became wheelchaired. He came to me with wheelchair bound, and we did the genetic on him, and it was dysphalinopathies or myopathy. And as I said, this steroid may cause myopathy to become very worse or very bad. So this may accelerate disability. So knowing the diagnosis, we can save him a few years of being wheelchaired, because this is usually a disabling, not a killing disease. Now, his brother, we said no steroid, and most of them is still ambulatory in their mid and late 20s. While this poor man, he was able to finish engineering school, but he was wheelchaired because of us. And this is where I talk about the protein. This is where the dysphylling, you see, it's part of the sacroiliac membrane. Let me give you another example of how can we save millions out of good diagnosis. This is a man who came with difficulty climbing stair for 5 years. He had proximal weakness and wasting of the hand. He could not squat or walk on his toes. His CK here was only 2 normal. The motor unit was myopathic. And this is his muscle biopsy. I don't know if you can show it. He has some inclusion in the muscle biopsy. And this inclusion where this is him, she has some atrophy in the hand muscle. This is a scan of the leg component. You see he had involvement of the posterior and lateral component of the thigh muscle. And this is his muscle biopsy using different immunostaining. You had this kind of what we call it moth-eaten in this picture, مثل العث اللي في العضلة. And he was diagnosed by another institution to have inclusion body-myositis. Inclusion body-myositis usually treated by a medication called immunoglobulin, IVIG. This medication costs about $10,000 every month, حوالي 40,000 ريال every month. So this man, he came to us after receiving 3 years of immunoglobulin, cost the government almost 1.6 million Saudi riyal. What we did the same thing, we found him to have a different entity of this. It's called LGMD1D, 1 minute thrombolysis dominant. So we stopped the immunoglobulin. This man finished his he's in muhasaba, accounting. He just invited me for his marriage a few weeks ago. We saved the government maybe 2 million. 2 examples show we can prevent disability, we can save millions. This was published recently, and as I mentioned, we could diagnose up to 80% of our families. I will end up. This is a similar study done in state. They have 55 families, exactly what we did here. They did in state, but they could, with the best effort, they could diagnose only 40%. We were able to diagnose 88% because of what I said, homozygosity among Saudi people. So this is another treasure in Saudi Arabia. With the technology, we can get better. So to sum it up, we can do two things. We can do as we usually do. We look at the patient, we take a clinical exam, we do blood testing, we can do muscle biopsy, immunohistochemistry, and then we'll go DNA targeting, or maybe, still this is a big maybe, and a lot of debate between me and my colleague, we can avoid all this and just go to the NGS and we find the diagnosis. This is still a work in progress. As clinicians, we need to continue our job as a clinician, but maybe the NGS, especially if we know the common mutation and the common disease in Saudi Arabia, will be useful. So to finish that, limb-girdle muscular dystrophy is a major cause of disability among Saudi, not only in Saudi Arabia, but also in Mediterranean basin. Actually, most of the muscle disease came من الحوض المتوسط. Wrong diagnosis, I mentioned, may cause to disability and waste of resources. The LGMD is still a big challenge. It's not easy. I think this bag has to be dissected and separated. We need to use the research, the scientific background, the collaboration between us. We just started the Saudi Society for Neuromuscular Disorder to look at these cases. Inshallah, we'll have more collaborative work, both in treatment as well as academic. As you know now, there's a lot of gene therapy. We have, for example, gene therapy for SMA, for Duchenne, and hopefully with many others to come. I would like to acknowledge my colleague at King Faisal at Department of Neuroscience, Dr. Kabler, Hatem Murad, Mohammed Mheza, Iftitah, and others, people who work with the Research Center. A special thanks to King Salman Center, to CATS for helping us in this project. Thank you.
Amazing work, Dr. Bouhlega. Thank you very much. And there's a lot to be done. It's just, I think it's just the beginning in controlling these deformities and these disabilities. So thank you very much for our speakers. And I would like, we are running out of time, but we can take two questions. إذا السادة الحضور يحبوا يسألوا ممكن ناخذ سؤالين. فإذا في سؤال تفضل.
الحمد لله رب العالمين والصلاة والسلام على أشرف الأنبياء والمرسلين. محمد حج العنزي، محامي سعودي وعضو الرابطة العربية للثقافة والفكر والأدب في دبي، ومعد برامج ثقافية ودينية في تلفزيون دولة الكويت سابقا. أشكر مولاي خادم الحرمين الشريفين راعي هذا المؤتمر، وأشكر مركز الملك سلمان للإعاقة ممثل بصاحب السمو الملك الأمير سلطان بن سلمان، وأشكر الضيوف والمحاضرين جميعا. أستاذ بوحليقة، يعني ذكرت الجينات. هل الجينات يعني تلعب دورا كبيرا يعني في تحديد الأمراض وزواج الأقارب والأمراض الأخرى؟ يعني بالنسبة للجينات عملها كثير يعني فيها في تحديد الأمراض والوقاية من بداية الأمراض في الأسرة. مستشفى الملك فيصل يعني له جهود كبيرة في الخليج العربي والوطن العربي والعالمي. يعني هل هناك يعني موضوع الجينات يعني هو موضوع مهم جدا يعني للوقاية من الأمراض، ويعني الجينات يعني أنا قصدي أنها التركيز على الأبحاث في الجينات، وأن الابن يأخذ 50% من الجينات من والده وكذلك من أمه. فموضوع الجينات يعني موضوع مهم جدا يعني. فما يعني النتائج التي وصلت لها هذه البحوث؟ الأستاذ التماظر يعني الضعف العضلي، ذكر الأستاذ بوحليقة أنك يعني تكلمت عن الضعف العضلي. يعني ما موضوع الضعف العضلي بالنسبة للجينات؟ يعني هل الجينات يعني تخفف من الضعف العضلي؟
شكرا لسؤالك، أعتقد واضح بروفيسور.
طبعا عشان الوقت بس نحاول نلخص الكلام. الجزء الأول صحيح، الجينات من أكثر مناطق في العالم فيها أمراض دينية ووراثية هي مناطقنا، وخاصة الجزء الوسط والجنوبي من السعودية. كل ما ابتعدنا عن وسط السعودية كل ما قلت، عشان الزواج فالجزء الأول من سؤالك صحيح الجينات، وهذا حقيقة كمان علشان تكوين السعودي جينوم بروجكت أو البرنامج أو السعودي جينوم بروجكت هو اللي هو مشروع الجين السعودي. هذا المستقبل، إنه عشان يكون كل واحد له طبيعة فحص للجين الخياطة الجينية. هذا السؤال الأول. واجبنا احنا كمسؤولين وكأطباء وكعلماء ان نجهز المعلومات هذه، اذا في علاج بالمستقبل يتعالج، اذا استطعنا نمنع كثير من الامراض فهذا هو علاجيه تشخيصيه وكمان يعني استقصائيه لمنع هذا. فاكيد نحتاج الجينات مهمه وكثيره جدا. بالنسبه للحثل العضلي وهذا مثل ما قلت في البدايه يمكن 90% في حوالي 1200 مرض بالنسبة للخلية، بس الخلية العصبية ناهيك عن الدماغ والسمع والشوف وكذا، في من 1200 مرض وشوي 95% منها جيني. فتخيل حجم المسؤولية اللي علينا وعلى في كل الخليج. طبعا الخليج متشابه، ان نبدأ نبحث على هالجينات، نتابعها ونحاول نحل المشكلة هذه. موضوع كبير جدا طبعا، صعب الواحد يجاوب عليه.
شكرا، يعطيك العافية. سؤال آخر؟ في سؤال؟ تفضل الأخ فوق. تفضل بس افتح الميكروفون. أيوة.
Yeah, thank you. My question will be directed to Chris, the first presenter. Chris, it seems that we have something in common. Myself, I'm blind. My name is Anwar. I also did a lot of sport activities and really challenging for us as blind people. You mentioned something about the chicken game. I think it's in orientation terminology, they call it facial vision, where you use your 2 ears to avoid obstacles. My question, Chris, when you mentioned about the architect, did technology help you a lot in getting the accurate measurements? And what about the third dimension? How did you cope with this in drawing? Thank you.
Okay, can you hear me?
Yes.
Yeah.
All right.
Yes, it's clear.
I'm not sure I fully understood your question, but boy, could you repeat that again? There was,
my point is, what did you do with the technology in getting the accurate measurement of the drawings?
Okay.
That's number one. Number two, what about the third dimension of drawing? How did you cope with it? You know, architect relies on the 3 dimension.
Right.
Thank you.
Okay, so for the first, dealing with dimensions, you can still work with scale, different ways of doing that, and I do have a tape measure. It's a talking tape measure, so it speaks out the dimensions if I'm measuring space, like in this space here, and all sorts of different devices for doing that. But then in terms of measuring the drawings, when I'm working on the drawings, it depends on the level of detail and specificity that you're working with. Some issues are very general, and others are very precise. And so there are ways to use graphic scales to be able to measure the drawings and to work with that. In terms of the technology, there's the second question was
or the 3 dimensions?
The 3 dimensions.
Yes.
So there's a process of sort of synthetic thinking. Something you learn to do as a designer is to think in 3 dimensions and to hold things in space in 3 dimensions. So there are ways of understanding the drawings. It's sort of like the mental process is there, the drawings are there. When I work with sight, I often would work with 2-dimensional drawings, just drawings on a page, but you're thinking in 3 dimensions. and sometimes you work with models, physical models, where you're actually building in the 3 dimensions and designing that way. So the process is very similar. I do work some with 3-dimensional drawings, and definitely with models. Physical models are very easy to work with, easy to design with, to change and do things. To work with 3-dimensional drawings, reading through touch, is very difficult, and it really takes an understanding of the plan and the elevations and all the 3-dimensional information within your mind to understand that, so you could read a 3-dimensional drawing. So in many ways, it would be really interesting to see how someone who's never had sight and wasn't trained as a sighted architect to be able to make that kind of connection and to understand things that you're designing in your mind in 3 dimensions and to understand that space. But I have the benefit of the 20 years and 2 degrees in architecture with sight to be able to relate to that experience of working without sight.
Thank you very much. Thank you very much, Christopher. We can have one more question. There is any questions? Okay, Professor Saiger, I want to ask you a question, please. Myself, being worked in universities for 20 years, being an academic, I know the role of universities in research and changing the perspectives of the societies. So being an academic, a scientist, you know the importance of neurorehabilitation and changing the vision of how things could be done in a country that has different sources of disability. And Dr. Bouhlega just mentioned genetics as one reason. So how can we motivate universities to participate in this aspect? What is the one message that you want to give academics in universities?
Well, the very shortest answer would be the access to the actual individuals needing the new knowledge, that is the patients. I mean, if you're a clinical academic person, if you're an academic person in neurology, urology, neurosurgery, neurorehab, unless you want to do only experimental work, you need to get access to the actual patients. And so if the university is very remote from the clinical settings, the scientists will not be on their toes in order to actually understand don't fix what ain't broke. How do you define the problem you want to solve? So I think it's absolutely crucial for the universities, and in my mind it's not difficult to motivate the best scientists to actually get in contact also with the reality in the clinic. So the best attraction would be the patients and not the clinical staff, actually.
Excellent. Thank you very much. Thank you. And Dr. Bouhlega, you have a question?
Yes, I have a question about Sweden and zero tolerance for traffic problem. In Saudi Arabia, as I don't know if you know, it has the highest number of MVA-related accidents. I hope it's not anymore, because of now they enforce the bylaw about speeding, doing an unprofessional thing. So where do you see? Because we just started this about 2 or 3 years ago. I know Sweden is a very advanced country. I've been there. I hope that in Saudi Arabia, what is your comment that how good enforcing the traffic bylaw will decrease the disability after the Swedish experience?
Well, I'm an old man, but when I was young, 1,000 people were killed in traffic accidents every year. 1,000 people. And now 200 a year, so it's only 20% of what used to be the situation 50 years ago, and we have increased the number of cars by a number of 10. So we have significantly lower traffic incidents, and of course that has a lot to do with education of the whole population and very strict laws. So we have speeding limits, we have safety belt regulations, and we have continuous education on a population level, starting from kindergarten and grade school through life. So and of course the cars are now much more safe. So of course it's not a quick fix. It's a very long and tedious work, and the zero tolerance for us is that we would like to get to the utopia of having no people killed in traffic. It's going to take some time.
Of course it is. Thank you. And one last question. Christopher, as an architect and a person with a disability, it is really important to have accessibility for people with disability to be able to participate, to be able to join the labor market, to be able to be active in the society. Accessibility is really an important tool. In Saudi Arabia, we are working on different programs to emphasize and promote accessibility for people with disability. I want you, as a person with experience as an architect, a person who went through the experience yourself of being a disabled, to send a message, to talk to the people, the owners of companies, the CEOs, the people who, the employers, to tell the society how important this is.
Wow. It's tremendously important. And I think about really about physical disabilities, and I've really thought about a lot about our role as architects and also people, whether we're owners of companies, facility managers, people that deal with physical space. One interesting way I've come to read about approaching it is the idea that a person with a disability isn't handicapped until a barrier, an obstacle is put in their way. And as an architect, who does that? Architects do. It's how we imagine space, it's how we design space. And in clients, for owners, it's in recognizing that importance, that with the right training, with the right rehabilitation services, you can really transform a disability into a characteristic, about something about that person. And it's only until the environment gets in the way that that disability really becomes a handicap. So that, to me, is an important distinction. And I think taking a little bit further into sensory impairments or other opportunities, it's technologies. Especially today, there's so much possibility in technology of making things accessible. And the importance that gives in terms of bringing people with disabilities into the mainstream, into the workplace, and to be really productive members of society, contributing members of society. So if it's designed right, if it's managed right, technology can open up possibilities that never existed before. Done wrong, it can create even more barriers than were there before. It can take things that used to be accessible and make them inaccessible. So as we develop these new technologies and as we develop new architecture, it is really important to keep that in front, not just to do the right thing, but to realize we have an active role in whether or not people with disabilities are fully included or not.
Thank you very much. I think I ran out of the time long time ago. So I would like to thank Mr. Khristopher Downie for being here, Professor Ike Saiger for being here, and Professor Saeed Bouhlega. And I would like also to thank King Salman Center for organizing such a wonderful conference and having this very fruitful session today. Thank you very much for the audience for being here, and I think after this session we have a lot to take home and think about to change the way we are doing things and improve our services. Thank you very much.